All right. Welcome, everybody. Day 3, I think, of TechEd 2014. Today, we will talk about Windows performance deep dive troubleshooting. So we will drill into the core of Windows and why performance is so important for us. Anybody in the room who doesn't have or didn't have at all Windows performance issues at one stage or another? I had. If I'm honest, I had. But we will give you the tools and the capabilities in this session so that you're able to resolve those performance issues. The agenda for today's session is we'll first talk about Windows performance lifecycle, so how Microsoft is measuring the success of performance for Windows and the application we are releasing. Looking into Windows internals, so specifically around how does Windows work under the hood so that you're able to understand later the information you're getting in performance analysis tools. Young will talk about Windows Performance Toolkit, myself around Windows Assessment Services. We are both premier field engineers at Microsoft. Young, what's your background?
So for the last 10 years, from 2000 to 2010, I was a senior support escalation engineer out of Charlotte, North Carolina. So if you guys ever opened a case, and that case was open for more than 4 hours, and it went for days or weeks, I probably have worked with you guys at some point. And for the last 4 years, I've been a premier field engineer out of Southern California.
Exactly. Myself, I'm based out of Dubai. It's a bit more sunny than Seattle, so that's why I chose that one. It's like 50 degrees in summer, so we are not usually going out. That's why I'm a little bit more heavier than him. Sorry about that. Okay. And what we will do is really showcasing you in real deep dive what's going on. Let's start with the Windows performance lifecycle. So why should we really care about performance? First of all, we want to make our end users happy. If the end user is happy, he will keep using the applications. And if I look into the recent case studies Apigee made, they realize that up to 80% of the users deleting or uninstalling applications because the application freezes or is slow in the response. In Microsoft, we developed a performance lifecycle, which we are using internally and which we highly encourage everybody to adapt as well. So basically, it is a concept of 5 different phases. It starts during the design for performance phase with learning. So you learn about performance, the behavior of your application. You plan the development. And then it's all about delivering a consistent experience for the user. So instrumenting, measuring, and analysis part. So the measuring and analysis part is a consistent process, right? So every time we ship a new operating system, every time we work on a new application, we measure the performance, do some analysis, and then we keep doing it for every major release, for any update we are doing. And this is what we are doing not only within Microsoft, like only within Windows. We do it for MOD, so Microsoft Office, Internet Explorer, all the products. And we are working strongly to get it over to msdn.microsoft.com and to encourage developers also to adapt this model. It is important. Why is it important? If you look into the performance fundamentals, it's based on 3 pillars. Users want fast experience. They want this snappy user interaction, right? They don't want that it takes so long for an application to start. It should be fluent, right? It should be smooth when they move from one click to another. And it must be efficient, right? It shouldn't drain the battery life, and it should not take a lot on disk footprint. So those are the performance fundamentals when we talk about how do we make sure that the application or a process or a driver is fast, is fluent, and is efficient. If you look into how this data is coming from, what is important to understand first is some of the basics elements of Windows internals and how it works under the hood. It is very important. We will not have the chance to cover Windows internals in depth. I think it's now Mark wrote two parts of his book for that. Windows internals part 1, Windows internals part 2. So it's pretty heavy. But let us share with you some information around the key aspects, the key principles which you should know about, the key areas. Let's take first for a second and talk about user and kernel mode. If you look into the user mode, we are running system processes in there the application, so any application you are starting on your computer, like Outlook, Internet Explorer, Firefox, whatsoever, you're running that in the user context, right? So that's all in the user mode. We have a kernel mode where the Windows kernel is running, right? So the name might guess that there's a kernel in there. And we got the Windows executive hardware abstraction layer to separate the application layer and the hardware so we can run it independently. And in between, we have a so-called ntdll.dll, which is kind of like a library. Every time your application say, oh, I need to create a new file, it goes and say, hey, ntdll, there is somewhere in your library a file called, or an execution called create file. Do that for me in the kernel. So that's the connection between the user and kernel mode. It is important to understand some of these fundamentals because later when we look into Windows Performance Toolkit, Windows Assessment Services, there will be no explanation anymore because the tool assumes that you know the basics around what is user mode, what is kernel mode. One more important aspect is how does a thread get really CPU time? And if you look into that, let's try to make it as basic as possible. We have a queue, right? So the threads are waiting. We have something called a CPU scheduler, which tracks the time and say, okay, what is in my queue? Do I let him in, yes or no? The CPU scheduler say, oh, I got thread 1, 2, and 3, thread 1 with high priority, thread 2 with medium priority, and thread 3 with low priority. Let me put them based on the priority levels to the next queue, to the ready queue. So here you can see in the example, thread 1 and thread 2 are moving to the ready queue, thread 1 with high, thread 2 with medium level. And then there's a dispatcher. He's responsible to execute immediately everything he finds in the ready queue. So he say, oh, there's thread 1. I need to put him on CPU. He needs to get some CPU lifecycle. He needs some time on the CPU. So then he moves that thread to the CPU. The last thing I want to briefly mention is around Windows Boot. Windows Boot and how it works. Because that's another important principle you need to be aware of because a lot of the performance cases Young and me are handling or anybody in our team is around slow boot. Right? We saw a lot of cases, 10 minutes, 15 minutes. And then we need to know, okay, in which phase, what is happening there? So we have the BIOS initialization phase. We got OS loader, everything around the operating system start there, and OS initialization. There's a little breakdown on it, and most of the support cases we see are in between OS loader till Explorer initialization. Obviously, kernel initialization, the kernel starts, so we load the Windows registry, we load system drives. Session initialization, that's where the user sees the user interface first time, right? You see, oh, waiting, 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 hopefully not too long after this session. WinLogon is the time where the user is able to enter his credentials. So he hits Ctrl-Alt-Delete, types in his credentials. It's the same time where we load group policies, computer group policies. And in between WinLogon and Explorer initialization, the user is entering his password, confirms it, and that's the moment with Explorer initialization where we start explorer.exe, and with that, user group policies are getting loaded as well. Lastly, we got post-boot. So that's everything which is not system critical, which we didn't have to have during the Windows boot time itself. So, for example, auto-delayed Windows services or applications which are scheduled to start, some of the scheduled tasks as well. Young, I know we have lots of different tools, right, for support analysis and performance analysis. But how do you compare all those different tools?
Right. So there are a lot of vast tools available to you guys. And you want to have a big belt to be able to use all these different tool sets. Now, everybody's very familiar with Perfmon to gather a big 10,000 level overview of what's happening on your system, be it client or server. And then from time to time, if you guys end up calling Microsoft support, we'll ask you guys for a memory dump, either a user mode application dump of a high CPU utilization, memory leak, or high disk latency or high network latency. And the other type of memory dumps that we have is the blue screen of death, right? Also known as a kernel dump. And for the developers, we have tools for Visual Studio to be able to live debug the problems that they have. But the problem with Visual Studio is that if an app or driver goes in production, you're not able to go ahead and attach Visual Studio on a production system, right? It doesn't scale that well. And that's where the Windows Performance Toolkit comes into play. It's very light. It takes up about 2% CPU on the systems. It works across the Windows ecosystem. So we're talking about Windows RT, Windows Client, Windows Server. And it doesn't matter what product that you're running on top of it. So if you're a SharePoint, IIS, file server, you're running SQL, Exchange, we're able to go ahead and take a look at a holistic view, not only at the user mode, which are the applications that you guys are running on top, but at the kernel level. So talking about a house, the kernel is like the foundation of the house, where if anything goes wrong on the foundation, right, the doors end up warping and the windows don't open up properly, right, and your applications are affected. So this toolkit lets you see a big, really dip into the issues that you guys are running into. That doesn't mean that tools like Process Explorer, which you guys are familiar with, are not helpful. Process Explorer, it's great at capturing data on your systems, but the only caveat with this is that, let's say that you want to engage your independent software vendor that sold you the software, or if you want to engage your NIC driver or storage driver, you can only take a snapshot, a screenshot of the problem that's occurring. So for example, I'm going to go ahead and start an application that consumes CPU here. And we'll see that it is consuming CPU right here. And a lot of admins and end users just come over here and they kill the process, right? That's consuming high amount of CPU. But instead of doing that, Process Explorer lets you go into properties, and then you could look at different information like this. And the one that a lot of administrators don't end up using is the Threads tab. The Threads tab gives you the functions that are running inside of that executable. So the work that is happening inside of the application. So in this example, it's a single-threaded application. And you can see that it's hcp.exe plus this huge offset. So by default, applications don't ship with the symbols. That's where you have to go to Options. And you guys see here where it says Configure Symbols. We have to point it to the symbol for that application. So in this example, we have this PDB file here. So I'm going to go ahead and copy that and then paste it right here. And I'm going to click OK. I'm going to go back to this eatcpu.exe, click on Properties. And so everybody knows about the Process ID and Task Manager. Inside of the thread, there is a thread ID that identifies which thread is using up the CPU. So in this example, we're using 12.5% of CPU. And we're able to click on Stack over here. And what you'll see is the work that executable is doing as soon as the UI becomes responsive. And so at that point, the nice thing about this is that you can take a screenshot of this, send it to the developer of the application or driver, and they may be able to look at the line of code where that function is being called and tell something about what's happening. Now, the problem with that is if that developer wants to see if there's anything else happening on their systems, this might not give the whole view. So do you guys see this? According to this tool right now, it goes into this main function, right, to start up, and then calls this function 1. But this is a single snapshot in period that we're taking. So if I go ahead and go back, we may end up seeing a different stack. And look at this. You see that? So you have to keep on refreshing, and you see that depending on where the clock cycle is or that thread is getting the CPU, it will show you different functions. So the same thing with user mode dumps. When you guys are asked to get a user mode dump, the reason that we ask you guys to get 3 to 5 user dumps is that one snapshot may not give us the whole view of what's going on in the application that's causing problems. Thus, the multiple dumps. Now, come this new tool called Windows Performance Toolkit, and we're able to go ahead and capture the data using the Windows Performance Recorder, which ships with the Windows 8.1 SDK. And it works for Windows Server 2012, Windows 8.1, Windows Server 2012, Windows 8.0, Windows 7, and 2008 R2. If you guys still have some 2003 servers, Windows Vista, or Windows 2008 systems, you need to go ahead and download the Windows 7 SDK.NET Framework 4.0 to be able to utilize this toolkit. With that said, you can see that the most type of issues that we end up seeing in the real world are listed here. CPU, disk I/O, file I/O, registry, networking. Heap usage is better known as private bytes, which is the #1 type of memory leak that happens in applications. Okay, so that's a great, tool to have in your toolbox that you guys have out there. Now, to collect the data, it's really simple. All we have to do is check this first level triage, and because we're troubleshooting a CPU issue, we just have to check on CPU usage. As soon as we do that, we could click on Start over here, and this is running in memory. So you can see that it's buffering about 4 gigs of memory out of my 28 gig system, and it's recording. So if I have this high CPU utilization, I'm going to be able to record what's going on. So I have this 10% CPU, 10 or 12.5% CPU utilization, and all I have to do is take for a trace for about less than a minute. So 30 seconds will work for me. And I could type high CPU in 8cpu.exe. I could go ahead and click on Save. And as soon as this is done saving, we're going to go ahead and open it up on the Windows Performance Analyzer. And this could take a little bit of time. So just to let you guys know, this tool is capable, again, of collecting 20,000 samples per second, depending on your CPU speed. So if it's a 2 gigahertz CPU, it's going to collect less. If it's a 3 gigahertz system, is going to collect more data samples per second. So we're not only able to look at the minutes, seconds, milliseconds, but microseconds. So for device developers, like if you're having problems with drivers, like NIC drivers or storage drivers, let's say you got a SAN and you're having problems with a HBA driver, we're able to go down to the 10 microseconds that is supposed to take care of an interrupt, or 100 microseconds that it needs to take care of this thing called DPC, Deferred Procedure Call. So now that it's done collecting the data set, we're going to click on Open in WPA, and it's going to open like this. And one of the things that you guys will see is that there is this thing called Graph Explorer, and we're able to see different graphs, right, called system activity, computation, storage, memory. There's a lot of information that is collected. One of the first things that I usually do is select under system activity this thing called Windows in Focus when that console application called eCPU was running. So this con host was up for about 8.5 seconds. You can see the duration. But what I'm interested really is in the amount of CPU. So under computation, we have this graph called CPU usage sample, and we could go ahead and drag and drop this graph. And one of the first things that she could do here is just hover over that high CPU utilization, and right away it tells you what process it is. It's HCPU.exe, and in parentheses, we see PID ID 4404. So I know that I'm in the right track, and you guys can see that as soon as I clicked on eCPU, it highlighted the area where HCPU.exe was running. So it's very intuitive. In this, on the amount of samples that was done, the CPU utilization was at 9.49%. So I could expand this, but there's not much information here by default. For those of you that have played with it, you could come here to right-click on any of the columns, and there are more options that you could go ahead and add. The first item that I will be adding is thread ID. Again, if it was a multi-threaded application like SQL, could have 1,000 threads running, worker threads, right? So you want to see which thread was the one that was using up CPU time. So in this case, it was thread ID 8624. So very similar to what we saw in Process Explorer. Now that we have this information, we could add the stack, which will give us the binary name and the function name. So the nice thing about this tool is, just like an Excel pivot table, anything to the left of the golden bar, do you guys see this? We're able to pivot data around that. So I moved the stack to the right of the thread ID, and we're able to expand this, and you'll see root, and you'll see these DLLs. Do you guys see the DLLs that are being called by each CPU? So we are able to see this type of information. Now, to be able to load the symbols, we have to go to Trace, Configure Symbol Path, and we have all this information here. This is the Microsoft Symbol Server, the public symbol server. There are other companies out there that also have symbols for their application. What I'm going to go ahead and do is add these symbols for the each CPU so you guys are able to see the functions that are being called here. And it's, depending on your network speed, it may take a little bit of time for the symbols to get downloaded locally to your system. But this tool, again, we use it to troubleshoot. Let me give you an example. We have troubleshot high SQL server, high CPU and SQL servers, memory leaks in SQL servers. We have troubleshot it for slow logins on Terminal servers and Citrix servers. We have troubleshot issues with Internet Explorer, for example, where it was consuming a high amount of memory. We have used it to troubleshoot group policies. So if you guys ever wonder why it is taking so long after you enter your username and credentials, we're able to use this utility to do that. For those of you that have domain controllers and have a high amount of CPU usage on LSAS, we're able to tell, once we get some information of is it LDAP queries that are happening from the clients, we're able to go ahead and trace that in conjunction with network monitoring tools like Netmon or Wireshark, and able to see what's happening on the wire and what's happening locally to the system. So it's really powerful. So with that said, we have our symbols loaded here, and you can see that just like we saw on Process Explorer, we are able to see information such as the main, and then function 1 was called. I'm going to go ahead and just look at the summary table, and I'm going to expand here, and you can see that function 1 ended up calling function 2 ended up calling function 3, and function 3 called function 4, 5, 6, and 7. And that's the thing. This gives you a big overview of what's going on, which Process Explorer, again, depending on when you click on the stack, you may see just function 1, you may see function 1 through 4, you may see only function 7, but this gives you the holistic view of what's happening on your systems. So with that, there are other things that we could do with this tool. And on servers, if you guys have 32 gigs of memory or more, you have to add this custom measurement called general profile for large servers to not use up a lot of memory on your servers. If you guys have .NET applications, we have this custom profile that we could share with you and have you guys troubleshoot your .NET 2.0 apps. By default, this toolkit is able to troubleshoot .NET Framework 4.0 applications. So let me go ahead and show you guys an example of a slow boot, slow logon. How many of you are on Windows 7 today? Wow, okay, so
How
most
many
of
on
you,
Slon XP?
wow,
It's getting
just-
less and less.
yeah, just 2. Okay, so not bad. Let's take a look at this boot trace. And the way that you look at the boot trace is by going to System Activity. And we could go ahead and go to the first graph that we're going to start out with is boot phases. So the boot phases shows us that this section, the pre-session init, is taking up 95 seconds, folks. 95 seconds. That's a long time. So in order to look at what's happening during the boot phase, we could always look at different items as CPU or disk. Look at this. During the initial period, there's a high amount of CPU, and then followed by a high amount of disk I/O. So we're going to start out with looking at the CPU, and again, we're going to start out with the CPU usage sample. And here we are at that point where for 95 seconds the system, was slow. It should that pre-init section should take about at most 10 seconds. It took 95 seconds. So we're able to zoom into this area like this by right-clicking on the graph, zoom in, and we can see that most of the CPU time is spent by the system process. And just like before, we're able to go to load symbols, so trace load symbols. And while the symbols are loading, we're going to go ahead and add stack, just to do a quick overview of what might be happening. So here we are with stack. And the thing is, the first thing that we see is we're in the kernel, start system thread, and then I could expand this by clicking on the right key here on the keyboard. And now that I have where the area of my high CPU utilization is, I want to look at the summary table a little bit. So I'm going to click on Display Table Only, and I'm going to expand this. And I'm going to keep on expanding. And one of the things that we see is that inside the kernel, we're on the NTFS file system. So NTFS, and we could keep on going. And it says NTFS device I/O control. So we're doing something with a driver. And call storage driver. And we're in the kernel again. And so on. And then NTFS calls a driver. And look at what it is, folks. VolSnap. Does anybody know what VolSnap is used for? It's for the volume shadow copy, right? So if your end user wants to restore a document, this is the driver that takes a snapshot and keeps, a copy of it, depending on the settings that you guys have. So in this system, somebody had created a whole bunch of snapshots of documents, and it's reading that information at the beginning. So for performance reasons, for enterprise customers, we highly recommend you guys to disable volume shadow copy so that your end users are able to store it on a file server, and that file server is backed up instead for performance issues like this. So it gives us a nice overview of what's happening with the CPU. The other thing is we still saw that there was a lot of disk I/O churn. So we're going to go back and see what's happening with the disk I/O. So the nice thing about this tool is that it gives us a lot of details. I'm going to go to storage, and I'm going to go to disk usage, and I'm going to go ahead and drag and drop the disk usage graph. The first thing that I would notice is that at this point in time, something happens where my disk I/O is at 100%, right? So my disk is 100% utilized. I'm going to go ahead and zoom in, and this is the beauty of this. It gives you this type of information. Do you guys see this? The disk I/O priority. So starting with Windows 7 and Windows Vista, we have different disk I/O priorities. So for those of you who do that do server, for SQL, you're supposed to turn off this so that it never goes to very low. The same goes for Exchange, and the same thing goes for if you're running an Oracle database. There's a registry key that you can turn this off. But on workstations, obviously you want to leave it the way it is by default. And then we're also able to see the I/O type. Is it reads or writes? So under normal, is it reads, writes, or is it flushes to the disk? And we're able to look at what processes are either reading or writing. So in this case, we're able to see that the disk is spending most of its time in reads, and this is the process that is using up the most amount of time, the system process, which is the kernel. Now, the nice thing about this tool is I'm also able to see the path name. So under the system process, I'm able to look at these different paths that are being accessed. And you can see that there's one called unknown, bitmap, MFT, and system32 drivers. You can see every single file that is touched when the system is, when we're taking the trace, either boot traces, or if you're troubleshooting a disk, slow disk, local disk, SanDisk, or even an iSCSI disk. So the nice thing about this is you're also able to sort it by size if you want to. So how much disk I/O is being done by these different processes. And just to let you guys know, unknown during boot is because of the caching that happens by the prefetcher and superfetch. And all that is loaded in memory during the boot process. So let's see what's happening with the superfetch. Is it working or is it busted on the system? So do you guys see this where it says miss? Most of our count is a miss instead of a red. Writes are good. Misses are bad. So what we're seeing here is that this system, for some reason, is not loading the items on disk into memory. I don't know if you guys knew this, but the normal reason for your Windows 7 systems, Windows 8 systems to be slow is because they are bottlenecked on disks. That's the number one reason of a slow performance. So there's a huge difference, as you guys probably noticed, between running an SSD on your workstation, a laptop, versus running a regular SATA drive, either a 5200, 5400, or 7200 RPM disk. With that said, the superfetch on the system is broken. The nice thing about this is that we do have a hotfix that solves a majority of Windows 7 performance issues. Do you guys know what hotfix that is? It starts with 2775511. If you guys haven't deployed that into your environment, it has about 90 hotfixes in one package. So it fixes a good chunk of these issues that you see here, not only with disk performance problems, it also fixes issues with group policies and network problems and file copy problems. So this is a high overview of what this tool is capable of doing. And with that, I'm going to show you guys that this tool also works with Windows phones. So here's Visual Studio. Under Tools, do you guys see this? Windows Phone 8.1, Developer Power Tools. The same exact UI is there under the Performance Recorder to be able to troubleshoot performance issues on your in-house Windows Phone applications. So if you guys have in-house applications that are running Windows Phone, you guys are able to use this same exact toolkit to go ahead and take traces of your systems. Let me go ahead and cancel over here. And let me show you guys this additional information that this tool is also capable of doing. How many of you guys have troubleshot slow disk I/O to your SAN or iSCSI NAS device?
A couple of them.
Okay, a few of you guys. Awesome. The cool thing about this tool is you could create these custom measurements and, excuse me, and you could go to, excuse me, let me go to my tech demo. And I could go to these profiles and look at this. Do you guys see this store port tracing? Store port tracing is at the lowest layer of where you're troubleshooting performance issues with on your server. So there is a store port for 2008 R2. In this example, I have a store port custom WPRP file to measure Windows Server 2012 systems. So let me show you guys what layer this is going ahead and tracing. If you guys look at this, this is where the mini ports such as store port or SCSI port end up sitting. And there's nothing between that and your hardware. So if the disk I/O is slow over here, more than likely, it's a problem with your multipathing software. It's a problem with your HBA not being tuned properly or the drivers being old. Or you got a problem between your HBA and the SAN somewhere, or something on the storage. This has been agreed with all the storage vendors that if the store port mini port tracing shows disk latencies, so anything more than 25 milliseconds, that more than likely it's an issue with the hardware of your SAN. So this is a quick and easy way of figuring out if the issue is on the server or if the issue is at the SAN. And because iSCSI just plugs into store port, you could use this same tracing in addition to like network tracing that you would normally collect to see if there are resets and different things like that, or a fiber channel trace if you're working with your SAN vendor. So there are a lot of customizations you could do. Not only these, but if you go to, if you run this command right here, xperf-providers, you'll see that pretty much for every single component that ships with the OS is instrumented. So you're able to add information such as group policy. You're able to add information as network connectivity to your systems, and so on. So there's a lot of nice things you could do. Now, the next thing that I'm going to show you guys is a quick demo of memory leaks. So for memory leaks, all I have to do is check this box for heap usage. Do you guys see this? And I'm going to go ahead and start a tool called Vermemp Test that leaks memory. And this is a tool freely available for download from blogs.technet.com, and just look for Aeromargosis. So this tool has this nice UI where you could do different things like leak memory. The only thing that you have to do is go into the registry, and let me go ahead and show you guys. Set this setting called tracing flags. So here's my VRMM test 64. So it's under HKey local machine, software, Microsoft Windows NT, current version, image file execution options, and I created a new key called VRMM test 64. Inside of it, there's a dword value called tracing flags that we have to set to 1. As soon as we do that, we're able to start, launch the application to start collecting memory information. And I could start leaking memory on this system, on this app. Obviously, your app would be leaking by itself, but for demo purposes, I'm leaking it on this demo app. And all we have to do is collect it for a very short time. And here we go. We're going to save this information. And again, we're going to open it in WPA. In here, the first thing that we need to do is make sure that our symbol paths are set up. So I have the public symbol server, and I'm going to add the symbols to this application right here. And I'm going to paste it. I'm going to go ahead and click OK. And here we have a section called memory. And in memory, we're able to see that there is a graph called heap allocations. The nice thing about this is all I have to do is drag and drop like that. And it already shows me that this process is the highest usage of memory at 4 gigs. Do you guys see this? It's that simple, drag and drop. If this was, how many of you have used debug diag to troubleshoot issues? All right, so you have to collect a dump, and then, if you're lucky, the built-in analysis will give you information. This is a lot simpler to use, folks. So I'm going to right-click on the column, and I'm going to add the threads to see how many threads were causing my memory leak. And I can see that is just one. Right, single-threaded. The other thing that I'm going to go ahead and do is add stack. So here's my stack. And I can move stack to the left like this. And I can already see all the DLLs, right? So now that I'm able to see the DLLs, again, I'm going to go to trace, load symbols. And again, depending on the speed of your internet, it may take as fast as 10 minutes. I've been at my own Microsoft Office. It took an hour and a half. So it might take a little bit of time to look at this data set. But in the end, we're going to be able to tell what function in the application was causing the memory leak. That's the nice part about it, is something that it would take you, if you had to look at a user mode memory dump, something that would take you probably at least 30 minutes, if not an hour or two, is done in a mere 10 minutes or so. So it's really useful. So the thing that we're going to be looking for here is we're going to go ahead and zoom into this area where the memory leak is happening. And now that we're zoomed in, we don't need to look at the graph. We're going to go back to the summary table. And we're going to keep an eye on the memory allocation here on the right side. So having a 24-inch monitor is definitely nice at your office. So if you guys don't have one, just make sure you tell your management that you guys need one now. All right. Okay, so with that said, we're going to go down here And look at this. It gives me this type of information. And by the way, I need to make sure that I'm sorted by size, because I think I just clicked on the wrong thing here. So you can see information that is useful like this. On button clicked, new byte, right? New byte. So memory is being allocated there. And that should call into an malloc. So for those of you that are familiar with C, you'll see malloc right here. And in turn, it calls an internal API called RTL allocate heap. So that's where the memory is getting allocated by this function right here. And if I had source code, let's say that I was the developer, I'm able to go to that level of that line of code and see where I am allocating the memory but not freeing up. So that's really useful. Again, it only took me, about 10 minutes? It took longer probably to load the symbols than for me to find where the memory leak was occurring. So with that, I'll pass on to Milad.
Sure thing. All right, so okay, so basically what Young showed is all about Windows Performance Toolkit, right? So where do you get it first? He started with it. What is the tool? So he has the Windows Performance Recorder to do the recording, and the analyzer where he spent the majority of the time to really analyze real data. You get it from the Windows SDK, or if you go a bit bigger, the ADK, the Windows Assessment and Deployment Kit, where you get even further applications. And just let me jump into a specific area. Is that going to work?
Yeah, the mouse.
The mouse is terrible.
Oh, okay.
Let's do this. Come on. Where's the mouse? Do you know the shortcut? Sorry about that. Okay, so that does Windows Performance Toolkit. But there's one more tool which we recently introduced for performance analysis on scale. Because it's nice what you can do with Windows Performance Toolkit, but if you're part of the image engineering team, for example, you will have some challenges to do these deep dive analysis over and over for every build you are running or you're about to release. So the engineering team and the Windows Performance team thought about that and introduced the Windows Assessment Services. The idea of WAS is to provide IT professionals who are in image engineering a test framework to measure performance, reliability, and the functionality of the operating system and the behavior of programs like Internet Explorer, the behavior of drivers on scale. How does it look like? You have a server where you are running the Windows Assessment Services server, the server role, let's say, and then you have the clients you want to test. This could be bare metal machines or virtual machines. You run an automated image deployment through that framework. So we use WDS and Windows PE in order to do the testing. We will collect the same information basically Young showed, so event tracing logs over there, and do automated analysis. Let me show you how that looks like. So that's Windows Assessment Services. It's a free tool, by the way. Like any tool we are showing, it's free, completely free. You just go download the ADK or SDK and install. And once you install, you're getting specific performance measurement scenarios. For example, driver verification, browser experience, Windows Store apps performance, startup and shutdown experience. If you click into one of them, you will get more details. So for example, the startup and shutdown experience will measure the system boot, shutdown, hibernate, and standby of that computer. The run of that job takes 2 hours and 30 minutes. It's available for x86 as well as x64, and it supports Windows 8 and onwards. So what it do is basically, if you click here on more information, it will go to Microsoft.com and provide you even more information. So here it will run first the job number 1, which is boot performance, so fast start up, and then standby performance. Obviously, I won't click now on run because I don't want to shut down my demo machine. But I prepared some of those scenarios for you. So here, for example, you see a report for driver verification, which I just took this morning from my own machine, 8 a.m. So it will give me information about my hardware itself first of all, CPU, the job name, when did I do it, the machine ID, so the computer name, and if I use a template, yes or no. If I drill into it, so it's all about driver verification here. So he found a couple of issues. So he identified, for example, some unnecessary drivers. So I could go now to driver management and look into, okay, who's the vendor, the OEM, who's shipping that, or what's really the driver about, and analyze and see if there's an updated version of that driver. I see multiple drivers here. Again, devices with multiple drives. So here I see, okay, that's a device name. That's grouped by OEM 15. It's coming from Intel. You see the current driver version. One other example is Internet Explorer startup time. So here, basically, what it does is it takes around 10 minutes, that job, and it starts Internet Explorer around 5 times and measures the time it takes to load the first page. Right? And then it will give me certain warnings or issues. So here, for example, create tab of IE launch assessment exceeded its threshold. So I could click on it now and look into the recommendations. Right here, it says, okay, iteration 1 took that long, 2, 3, and so on. And I get immediately the recommendations, how I can mitigate it. And remember I was saying it is more lightweight for image engineering, and Windows Performance Toolkit is more in-depth. That's basically what he says as well, right? For more extension, use WPA to investigate further. Right? But it will give you a general idea where to drill into. Same counts for Windows UI performance. Again, I'm getting here deep dive information around what's going on. Boot performance, so that's my own machine. It noticed that there are some optimizations which could be done by my OEM. So here it says setup special was not complete by the manufacturer, right? And then the recommendation for it. The manufacturer should run the setup specialized before the end user receives this computer. So in general, Windows Assessment Services will give you a lot of information on a high level how to optimize your image before you run it into the production environment. So if I just switch over here for a second again. What are the requirements in order to get Windows Assessment Services? We quite recently announced it when we shipped Windows Server 2012, Windows 8 release. So it requires Windows Server 2012. It is recommended to have at least 1 gigabyte of NIC. And you should have disk space, because as soon as you start doing lots of runs through Windows Assessment Service, it will obviously take a lot of disk space because it's generating lots of traffic and it's collecting all this data on the server and so that it can analyze it. If you look into the test computers itself, what you need to do is it must be Windows 8 or onwards, right? So Windows 8, 8.1, Windows 8.1 Update 1. I still believe, hopefully, we will change the naming one day. It's getting a challenge. And particular USB support for USB and Pixie boot support if you want to do bare metal deployment tests. So you can say WAS should start a bare metal deployment, and it will measure you the entire deployment process, and will tell you, okay, at this phase, I will recommend you to do this instead of what you're doing right now. You need to have a DHCP server, right, for if you're doing the bare metal deployment. WAS need to know, okay, where those clients are. Some tips and tricks around WAS. You need to install it on a server computer. And then you have the Windows Assessment Services client, which I just showed you on those client machines if you're doing analysis after the boot time. Alternatively, you can also have a standalone version, everything in one box, which I have on one of my other machines. So you can have the server and client on one machine if you want to drill down into your own machine. Around the setup itself, you need to add certain drivers, because if we are talking about bare metal deployment, Well, guess what? If you want to do bare metal deployment analysis, WAS need to know, okay, what is the network driver, what is the network card you're using, so that it can communicate to PXE with the machines and do this analysis for you. So you need to add the NIC driver, and then you need to prepare the Windows PE USB drive for the test computer inventory. You can add lots of more drivers, so you can really make it look like your own image, right? You can add your out-of-the-box drivers, you can add your applications to that image. That's all possible. We see more and more enterprise customers getting interested in it because it just saves time from doing the usual, hey, let's start WPT, let's do a trace. Oh, okay, I found this issue, let me drill into it. Most of the time, the first things you will see in WAS are really the current roadblockers you have in your image engineering process. So this will give you a high level and quickly the information needed in order to do the Windows deployment. If you cannot solve it with WAS, with Windows Assessment Services, then what I will really recommend is using, like Yong showed, Windows Performance Toolkit, because there you can really drill into the material and see, okay, where is this threat, which function is it calling, why is it happening? So that's the WPT scenario. Let me just jump into here one more time. All right. One of the other things I really want to show you around WAS is you can also run individual assessments, and you can combine them, right? So because we have certain scenarios in place, right? Like browsing experience, which combines IE security software impact, mini filter diagnostics. Over here, first one, second one. But we will give you, with the tools, the freedom to choose, okay, say, hey, I want to have my individual assessment. So what you need to do is you click on Run Individual Assessment, and then you can just select what you want. Right? Maybe you want to check the file handling. So it measures the duration of common functions like copy, move, delete, and zip. You can analyze the memory footprint, takes an hour. Mini filter, lots of information. Like you can even measure how long it takes to open, view, or search for photos, right? So some of the most common tasks end users will do. So before the end user calls you and say, hey, every time I open my application, it's so slow, you can have a KPI for that and say, no, actually, with the corporate image you have, it will take you like, I don't know, 1 to 1.2 seconds to start this picture. Same counts for media player performance. So here, what it does basically, as soon as I launch it, it will start Windows Media Player over and over and start sample videos, right? And then it will tell you, okay, how long did it take to decode that video file? What was the quality? Was it really full HD you're seeing? Was it maybe 4K? So you get all of these informations. Some of the lessons we have learned so far from WAS since its launch. Right now, it can assess one computer at a time. So if you're running multiple tests for, like, let's say 10 machines, it will start with one machine, finish that job, move to the next machine. It doesn't support yet Windows RT, so Windows Runtime, which runs on ARM processor like the Surface 2. And really, when you look into WAS, it is a really high-level tool to get started around, okay, what does the image look like? Is it fast enough? Is it fluent enough? And what could be the potential user experience if you look into video processing, picture processing? If you really want to drill into that, you need to have WPT. Right, Jan?
Yes. And we could show them a hang analysis so that, how many of you guys ever had Outlook hang or IE or your in-house application? Has anybody have the apps hang?
I have.
Now, besides killing the app, what have you guys tried doing besides killing it? Is that what everybody does? Is that a common thing, I would say? The nice thing about the Windows Performance Toolkit is that we're able to go ahead and tell you guys what's going on. So how many of you have ended up using the Windows Resource Monitor? The Resource Monitor? A lot of folks, right? So let me ask you guys this. Have you guys ever noticed this thing called Analyze Weight Chain? Oops. Got. Let me try this again. Right click. Have you guys ever noticed this? Analyze Weight Chain is built in, right, to Resource Monitor. Now the thing is that a lot of times this will only tell you what thread might be hung on. It will not tell you what that thread is doing for a living. Is it waiting on network? Is it waiting on disk? Is it waiting on CPU? And the nice thing about the toolkit is it will tell you exactly what's waiting on. So here we go back to the application called Vermem Test. And I'm going to hang this for about 30 seconds. Do you guys see this? It says Hung UI. And I just punched in 30 seconds. So what I'm going to do is bring the Windows Performance Recorder. And all we have to do is check the box for CPU usage and click on Start. It's recording. And I'm going to hang this UI. So I can't move it now. And if I go back to the Resource Monitor, I'm going to click Analyze Chain. It says but now it says it's not responding, right? That's all it's able to tell me. Because we're running the Windows Performance Recorder, we'll be able to get you guys root cause of what happened to that application. Why did it go to lunch for 30 seconds and came back? Or why might have gone to lunch and never have come back? So with that, so the hang was complete. And I'm just going to save this trace again. And again, depending on how much data I'm collecting, it may be faster or slower. And these files, let me tell you this, don't run it for an hour. If you run this for an hour, you may run out of disk space. These files could end up getting to 5 gigs. I think the biggest that I've seen it was 32 gigs, folks. So be careful. Run it for a very short period of time. So here we go. We're opening up the Windows Performance Analyzer. Let me bring it to the screen. And when you're troubleshooting a hung application, and by the way, this works also if your machine just hangs for like 5 minutes and comes back. You look at perfmon, and there's no data, right? There's just a blank line. This tool will still collect information and tell you exactly what driver caused your machine to hang. It could be server, client, or Windows Phone, Windows RT systems. With that said, the first thing that I need to do, because it could take a long time to load the symbols, I need to make sure that I pointed to the symbols for this particular application. So let's say that the dev is in-house and give me the symbols. I'm going to click OK, start loading the symbols before I do anything. And I'm going to go to System Activity. The nice thing about System Activity, as you guys can see, has this graph called UI delays. So it makes life easy. Here we are, and for 30 seconds, this application was delayed, right? And here we have 30 seconds. So under Message Check Delay. So all I have to do now is zoom in to this area. Now that I know where my application was hung for 30 seconds. Minimize this. And instead of going to computation, CPU sample, we're going to go to this new graph called CPU usage precise, folks. Okay? And we're going to go ahead and drag and drop CPU usage precise. And for those of you that are going like, man, I wish I had those columns set up the way that he's doing, Andrew Richards has a link that we'll be providing to you guys on the deck that has these templates where it sets up all these columns properly so that all you guys have to do is come to Profiles, Apply, browse, and then just apply the templates. So here's an example. So I have for high CPU, high disk I/O, high DPC interrupts. So this is if you're having driver problem. Slow boot, slow logon. So for those of you that are doing Windows client, and wait analysis. This is the hang analysis. So I'll show it to you guys in a little bit. But going back, the columns that we need for hang analysis is I have to right click, and we have this column called new thread stack. This other column called rating thread stack, and we're done. Now, because it has to reload the symbols, the UI will be unresponsive while it's doing the things on the background for a little bit of time. That's okay. So we'll give it a time. But in the past, what you had to do if your application or your system hung, do you guys know that if your system hangs, instead of having to hit the power button, you could blue screen the system and get data out of it? How many of you guys knew that? Servers and clients. Okay? You could blue screen the system and actually get data and find root cause analysis. Obviously, analyzing the dump, it's really difficult, right? That's why we have ex-developers that all they do for a living is daily look at memory dumps. And the same thing goes with application hangs. We have guys that develop for a long time that end up looking at those user mode dumps, those Windows error reporting dumps, that when you have application crashes or when you have application hangs, the little word comes up. We're able to get you guys root cause analysis, but obviously it takes time and a lot of patience. But with this tool, life is easy. All I have to do is move this, do you guys see this, where it says weights max? All I have to do is move this to the right of the golden bar and then sort it by that. And I need to look for my application that was hung. So the first thing that I need to do is remember what the process ID was, 8068, just in case if I had multiple versions of the application. So I'm going to go ahead and look for virtmem. I'm going to click Next. Here we are. And the next thing I need to do is find out what thread it was. Do you guys see this? It was thread 6588. So I'm going to go back, to CPU usage precise, and I'm going to look for 6588, and here it is. Because I had my symbols loading at the beginning to save us time, I'm going to go back to summary table, and look at this beauty, folks. I'm going to be able to tell why it hung. So keep an eye on the right side. It was hung for 26 seconds. As I was telling you guys before, microseconds, milliseconds, and seconds. So it's very detailed. So if you're a financial company doing trades in milliseconds, this is the tool to use to find out how to make it run faster. So, or even if you have a SharePoint site, you want to make it run faster, use this tool, guys, and find out where in your code the bottleneck is. So with that said, I'm going to keep on going. And here we have this function that says on button click, go and hang. And look what's been called right underneath that. Sleep EX delay execution, folks. So that function right there called Sleep EX made the app hang because it was sleeping, right? So believe it or not, we had a customer that had a third-party application where during logon, Explorer would not come on for 5 minutes. The third-party code was calling SleepEX 10,000 times for 5 seconds. 10,000 times for 5 seconds, right? So we're able to tell this type of detail with this tool that in the past, you would have to get a memory dump, and it's super difficult for folks that don't look at code like us, like IT pros like ourselves. It's difficult. So this tool makes life a lot easier to get to the bottom of issues. With that said, that's the end of this demo.
Yeah.
Thanks, Milan.
So, well, with that said, I mean, we are nearing the end, and we will be actually open for Q&A now. If you don't have any questions, thank you so much for attending.
Thank you.
Thread 1 with high, thread 2 with medium level. And then there's a dispatcher. He's responsible to execute immediately everything he finds in the ready queue. So he say, oh, there's thread 1. I need to put him on CPU. He needs to get some CPU lifecycle. He needs some time on the CPU. So then he moves that thread to the CPU. The last thing I want to briefly mention is around Windows boot. Windows boot and how it works. Because that's another important principle you need to be aware of, because a lot of the performance cases Young and me are handling, or anybody in our team, is around slow boot. Right? We saw a lot of cases, 10 minutes, 15 minutes. And then we need to know, okay, in which phase, what is happening there? So we have the BIOS initialization phase. We got OS loader, everything around the operating system start there, and OS initialization. There's a little breakdown on it, and most of the support cases we see are in between OS loader till Explorer initialization. Obviously, kernel initialization, the kernel starts, so we load the Windows registry, we load system drives. Session initialization, that's where the user sees the user interface first time, right? You see, oh, waiting, hopefully not too long after this session. WinLogon is the time where the user is able to enter his credentials. So he hits Ctrl-Alt-Delete, types in his credentials. It's the same time where we load group policies, computer group policies, all the products. And we are working strongly to get it over to msdn.microsoft.com and to encourage developers also to adapt this model. It is important. Why is it important? If you look into the performance fundamentals, it's based on 3 pillars. Users want fast experience. They want this snappy user interaction, right? They don't want that it takes so long for an application to start. It should be fluent, right? It should be smooth when they move from one click to another. And it must be efficient, right? It shouldn't drain the battery life, and it should not take a lot on disk footprint. So those are the performance fundamentals when we talk about how do we make sure that the application or a process or a driver is fast, is fluent, and is efficient. If you look into how this data is coming from, what is important to understand first is some of the basics elements of Windows internals and how it works under the hood. It is very important. We will not have the chance to cover Windows internals in depth. I think it's now Mark wrote two parts of his book for that. Windows internals part 1, Windows internals part 2. So it's pretty heavy. But let us share with you some information around the key aspects, the key principles which you should know about, the key areas. Let's take first for a second and talk about user and kernel mode. If you look into the user mode, we are running system processes in there. The application, so any application you are starting on your computer, like Outlook, Internet Explorer, Firefox, whatsoever, you are running that in the user context, right? So that's all in the user mode. We have a kernel mode where the Windows kernel is running, right? So the name might guess that there's a kernel in there. And we got the Windows executive hardware abstraction layer to separate the application layer and the hardware so we can run it independently. And in between, we have a so-called ntdll.dll, which is kind of like a library. Every time your application say, oh, I need to create a new file, it goes and say, hey, ntdll, there is somewhere in your library a file called, or an execution called create file. Do that for me in the kernel. So that's the connection between the user and kernel mode. It is important to understand some of these fundamentals because later when we look into Windows Performance Toolkit, Windows Assessment Services, there will be no explanation anymore because the tool assumes that you know the basics around what is user mode, what is kernel mode. one more important aspect is, how does a thread get really CPU time? And if you look into that, let's try to make it as basic as possible. We have a queue, right? So the threads are waiting. We have something called a CPU scheduler, which tracks the time and say, okay, what is in my queue? Do I let him in, yes or no? The CPU scheduler say, oh, I got thread 1, 2, and 3, thread 1 with high priority, thread 2 with medium priority, and thread 3 with low priority. Let me put them based on the priority levels to the next queue, to the ready queue. So here you can see in the example, thread 1 and thread 2 are moving to the ready queue. All right. Welcome, everybody. Day 3, I think, of TechEd 2014. Today we will talk about Windows performance deep dive troubleshooting. So we will drill into the core of Windows and why performance is so important for us. Anybody in the room who doesn't have or didn't have at all Windows performance issue at one stage or another? I had. If I'm honest, I had. But we will give you the tools and the capabilities in this session so that you're able to resolve those performance issues. The agenda for today's session is, we'll first talk about Windows performance lifecycle, so how Microsoft is measuring the success of performance for Windows and the application we are releasing. Looking into Windows internals, so specifically around how does Windows work under the hood so that you're able to understand later the information you're getting in performance analysis tools. Young will talk about Windows Performance Toolkit, myself around Windows Assessment Services. We are both premier field engineers at Microsoft. Young, what's your background?
So for the last 10 years, from 2000 to 2010, I was a senior support escalation engineer out of Charlotte, North Carolina. So if you guys ever opened a case, and that case was open for more than 4 hours, and it went for days or weeks, I probably have worked with you guys at some point. And for the last 4 years, I've been a premier field engineer out of Southern California.
Exactly. Myself, I'm based out of Dubai. It's a bit more sunny than Seattle, so that's why I chose that one. It's like 50 degrees in summer, so we are not usually going out. That's why I'm a little bit more heavier than him. Sorry about that. Okay. And what we will do is really showcasing you in real deep dive what's going on. Let's start with the Windows performance lifecycle. So why should we really care about performance? First of all, we want to make our end users happy. If the end user is happy, he will keep using the applications. And if I look into the recent case studies Apigee made, they realize that up to 80% of the users deleting or uninstalling applications because the application freezes or is slow in the response. In Microsoft, we developed a performance lifecycle, which we are using internally and which we highly encourage everybody to adapt as well. So basically, it is a concept of 5 different phases. It starts during the design for performance phase with learning. So you learn about performance, the behavior of your application. You plan the development. And then it's all about delivering a consistent experience for the user. So instrumenting, measuring, and analysis part. So the measuring and analysis part is a consistent process, right? So every time we ship a new operating system, every time we work on a new application, we measure the performance, do some analysis, and then we keep doing it for every major release, for any update we are doing. And this is what we are doing not only within Microsoft, like only within Windows. We do it for MOD, so Microsoft Office, Internet Explorer,